Okay, Lamai. Good evening. Can you hear me? Ma'am, I on. Okay.
Recording in progress.
Okay. Good evening, students. Today we are discussing April monthly test paper, the second structured essay and the essay questions were there in the paper. And in last few days, time to time, we could finish our discussion about MCQs and the first structured essay. Right? And to your group, I added all the recordings, so you can access them there and refer them again and write a review. As we discussed in the class, we should start writing reviews from from this paper, April paper. Okay, so complete the review. Okay, we are discussing it fully, and yeah, today we are going to discuss about the second structured essay and the remaining essay questions. Okay, so I'll make this as a brief discussion anyway, but still the special points, important points I'm going to emphasize. Okay, right. So this is our paper. This is our paper. So we discussed the first structured essay. Now we are discussing this. Okay, look at the question. The following compounds are present separately in four test tubes: A, B, C, and D, not in order. And the compounds are barium carbonate. Then the other compound is potassium nitrate, KNO2. And then you have lithium nitrate, LiNO3, LiNO3. And then the final one is magnesium carbonate, MgCO3. Okay, magnesium carbonate. Now look at the question. It's telling each compound in the test tube was subjected to strong heating. Okay, we are heating that strong. So that means Lamai, strong heating you can write there. Strong heating is thermal decomposition. Okay, so that means we apply heat on these compounds and we decompose them into their respective products. Okay, so that part we need to remember from inorganic chemistry. Okay, so that means what each compound, each ionic compound is going to give you after decomposition, we need to remember it from inorganic chemistry. The inorganic වල මේක කොහෙද තියෙන්නේ ළමයි? In inorganic chemistry you study this one under S block. හරිද? That I gave you that note in under the S block. Okay, so under S block we learn thermal decomposition reactions of nitrate, carbonates and bicarbonate. So you are looking at a question that is asked from that certain theory area. So this is KNO3. Okay, so nitrates thermal decomposition and carbonate thermal decomposition. Okay, so let's try to solve this problem, right? So before that, Pute, I'll write all the thermal decompositions of these reactions. Okay, so by that way we can start a good discussion. Okay, so now remember about carbonate and nitrate thermal decompositions. Okay, so if it is a carbonate, then the carbonate and nitrate both lamai we classified into three sections. Okay, we classified them into three sections: carbonate and nitrates. Okay, so there are three groups actually. So first category, I write it here. Uh, yeah, first category, second category, and third category. Okay. To the first category, what are the ionic compounds that will belong to? All group 1 except lithium. Okay, without lithium, except lithium, you have all the group 1 elements. Okay, to the second category, we have lithium, then we have group 2, then other moderate reactive metals. To the third category, Lamai, we have weak metals, or you can say, yeah, weak metals, or you can say simply low reactive metals were there in the third category, low reactive metals. Understood? So then, depending on the thermal decomposition way, okay, so reactions would be different. හරිද? හොඳට මතක් කරගන්න මම ඔක්කොම මේවා ටික කියනවා ළමයි. Okay, so use this part to remind that theory area. හරිද? ඉතින් මතක් කරගන්න මේකේ. So if it is a carbonate, if it is a group 1, the section 1 carbonate, they are not going to undergo thermal decomposition. They are thermally stable. Okay, so when you heat them, they just melt without decomposing. Right? And if you go to the second category, those carbonates are giving you oxide and carbon dioxide. Carbon dioxide as the gas. But if you go to the third category, the special thing is about this third category carbonates today, their oxide is unstable. Now, one example that is belong to these low reactive metals is silver carbonate. Silver carbonate, write the reactions here. So silver carbonate is going to give you, after thermal decomposition, silver oxide and carbon dioxide. Right? But the problem is this silver oxide is unstable. So this silver oxide undergo further thermal decomposition, further decompose to give you silver metal and oxygen. Silver metal and oxygen. Okay. So then if you balance it, this is how it look like. Understand? So then if it is a third category carbonate, the overall reaction would be what? They are going to give you finally not the oxide, they are going to give you the metal. Right? Metal, carbon dioxide and oxygen. So it is giving you two gases, but the group second section carbonates are giving you only one gas, carbon dioxide. Now I hope that is clear to you. So that's about carbonates. Now we will be needing that one. Right? But if you analyze our carbonates, lamai, both are barium carbonate and magnesium carbonates are in the second category carbonates. Second category carbonates. Understood? Second category carbonate. So then they would be decomposing to give you what? Oxide and carbon dioxide. So we'll write the reactions also here itself. I think it would be better. So magnesium carbonate, I write it here again. Magnesium carbonate going to undergo thermal decomposition and give you magnesium oxide and carbon dioxide. Here it will give you barium oxide and carbon dioxide. Barium oxide and carbon dioxide. Understood, Lama? Okay. Then, what about their nitrates? The next part is about their nitrates. So nitrates are thermally decomposing to give you, and the first category nitrates are undergoing thermal decomposition. Okay. So they will give you nitrite and oxygen gas. Nitrite and oxygen gas, NO2 minus and NO2 gas. Okay. So second category nitrates, they are going to give you again oxide, then NO2 gas, NO2 gas. Now NO2 gas is a special gas, Lamai. Why? You remember they are having a color, ne? NO2 has a color, brown. While other gases I mentioned here are colorless, NO2 is brown, right? And the final, the low reactive metal nitrates, now you can guess what will happen. Just like earlier, it is going to give you the oxide, just like similar to the second section. But the problem is their oxides would be unstable. So finally, it will give you the metal. I can write it like the metal, NO2, and O2. Anyway, O2 was the product. So these are the three reactions, three types. Understand? So you need to remember this exactly. So when I'm marking your papers, I saw some of you are having kind of doubts, and some of you have actually forgotten that theory area. So then I especially wrote a sentence for you to encouraging for you to refer that part again. හරිද? එතකොට ඒ මං කියපු විදිහට පුතාලා එක පාඩම් කරන්නත් ඕනේ. හොඳේ? හරි මං ගොඩක් අය එහෙම ලිව්වා. මෙහෙම බලලා මදි පොඩ්ඩක් තව බලන්න ඕනේ කියලා ඒ ටික ඒ විදිහටම කරන්න. Okay, so that is what we need to do with it. Okay, we need to improve our results නේ. කොහොම හරි අපේ result එක වැඩි කරගන්න, හොඳ කරගන්න තමයි හැමදේම කරන්නේ. හරිද? Right. So we'll discuss that later. So anyway, now since we know the nitrate thermal decompositions, we can write these reactions too. Now potassium nitrate is a first section nitrate. It is going to give you potassium nitrite, KNO2 and O2. Right? We need to balance this. Now earlier magnesium carbonate, barium carbonate decompositions are balanced. But potassium nitrate thermal decomposition is not balanced. You can see there are 4 oxygen atoms in the right side, but only 3 oxygen atoms in the left side. To balance this one, we put 2 in front of both compounds. Now you can see 6 oxygen and this side also having 6 oxygen. It is balanced, right? But when you go to the lithium nitrate thermal decomposition, this is also some people get kind of mixed up. So it is, even though it is in the first group lamine, lithium nitrate, lithium carbonate, they behaving, their decompositions are kind of similar to second group. This is a very good example to show you the diagonal relationships between first and second groups. Okay, so lithium, which is in the first group, actually behaving like magnesium. Most of the properties of lithium are similar to magnesium. Lithium is more reactive, by the way, but still in some aspects there are reactions, like let's say the carbonate thermal decomposition, nitrate thermal decompositions, and the reaction with nitrogen, reaction with oxygen, they are kind of mostly similar. Okay, so then the reaction will give you lithium oxide. Now I said it is going to give you the oxide, oxide NO2 and O2. Now you can see it is not balanced, but anyway, with the time you should remember how to balance it also. Let's put 4, 2 and 4 here, then it will get balanced. Right? Here you have 12 oxygens. Check this side. This side will also have 12 oxygen atoms. Right? I hope it is clear to you, Lamai. This is how you get the 4 reactions and how they balanced, how they are getting balanced. Okay. Now let's go to our question and see how did they introduce these things. Now check the residue part. They're describing it, and there's another part also, brown gas. Now they're telling about the gas also. So there's only one brown gas here, NO2. NO2 is given by lithium nitrate, no? So this A must be lithium nitrate, isn't it? This A must be lithium nitrate. Okay, because that's the only thing that gives a brown color something. So then others are giving you colorless gases, which is CO2 and O2. So then that the second column, you can't use it further to identify BCD. To identify BCD, you must shift into the next side, the residue side. Okay, now look at the residue of B. Residue is insoluble in water. Then look at the residue of C. It says with dilute HCl, it will give you a brown color gas. And then the D residue, it is again soluble in water. So now we need to look at the reactions with water and HCl. So now these are the residues. No, these are the residues: magnesium oxide and barium oxide and potassium nitrate. Now when you react this with HCl, let's take with HCl. Now let's say you are reacting magnesium oxide with HCl. So it's going to give you magnesium chloride and water. That's it. There is no gas. No gas, no brown color gas also. Okay, so that means, Lamai, this cannot be magnesium oxide or barium oxide. It will do the same thing. And then the other one must be this one. Sorry, you already identified this one. It should be KNO2. So when it is added with dilute HCl, I hope you remember this one. NO2 minus, there is the special part here, Pute. NO2 minus is a special anion. It is an anion that is capable of releasing gases with dilute HCl. Remember, under analysis tube, we learned that one. Under the anion identification, nitrate is an anion that can release Nitrite is an anion that can release a gas with dilute acids. Okay, so what would be that gas, Laman? Okay, so we can write it as HNO2, HNO2 and KCl. And that HNO2 is unstable, it is going to give you NO, NO2 and water. So this NO2 is the brown color gas that we discuss here. Okay, so that means, Laman, that uh, salt must be KNO3. So look at the note again. So according to the text, with dilute HCl, the one that releases brown color gas is C. C must be lithium nitrate. We don't know about B, but we can say for sure what is C. C is potassium nitrate, KNO3. Understood? Then C and B and D will be barium carbonate or magnesium carbonate. Okay. For that, we need to check their reactions with water. You understand? We need to check their reactions with water. Now, if you take barium oxide, now let's write their reactions with water. If you take barium oxide with water, it is going to give you barium hydroxide then H2. H2O, water. Only barium hydroxide, sorry. And if you take magnesium hydroxide with water, this is a very good question. It is going to give you magnesium oxide with water. It is going to give you magnesium hydroxide compound. Now, if you analyze these two compounds, these two products, okay, you remember again, there's another theory that was there on this block that I gave you. It is about solubility rules. Solubility rules. There were 7 sentences and 1 table. That means altogether 8 rules regarding solubility. You remember the table number. In that table, we assessed the solubilities of mainly sulfates and hydroxides. We said that sulfate solubility decreases downward the group 2. Now, we assessed in that table nama magnesium, calcium, strontium and barium cations. So solubility of sulfates decreases downward the group. That means they become more and more insoluble. But solubility of hydroxides, that increases downward the group. So if I exactly write what was there, okay. So there was like this magnesium hydroxide, then calcium hydroxide, okay, then strontium hydroxide, then finally you have barium hydroxide. So hydroxide solubility was increasing. We represented that one by arrow. So this is fully soluble. Understand? So that means, Lamai, they are telling one of the product is soluble and one of the product is insoluble. Now we can identify exactly what those compounds are. Is it barium carbonate or magnesium carbonate? Check the note, Pute. Check the question. B is the residue that is insoluble in water. That means this must be B. Okay, that means B is magnesium carbonate because this is insoluble in water. Can you see? Insoluble in water. Okay, so then D must be barium carbonate. So that's how you argue and come to the answer. Now you can understand, Pute, it is a very good question and it is not only from the S block. හරිද S block එකෙන් විතරක් නෙමෙයි යෝග අහලා තියෙන්නේ. තේරුණාද? S block එකක් තියෙනවා. Not only that, right? Thermal decomposition, solubility rules, anion identification, everything is there. ඉතින් ඔන්න ඔහොමයි exam හොඳ questions design වෙන්නේ. Right? So everything that I'm giving to your papers. දැන් ඔයාලගේ papers වලට දාලා දෙන හැම question එකක්ම ඔන්න ඔහොම ඒවා තමයි තියෙන්නේ. Most of the questions are prepared by me and I kind of borrow some other questions from other papers. Test papers එන්න පුළුවන්, past papers එන්න පුළුවන්, model papers එන්න පුළුවන්. මම සමහර ඒවැනුත් questions අරගෙන දානවා. හරිද? එතකොට ඕක හොඳට ඔය questions කරන්න ඔයාගේ brain එක හැදෙනවා. ඔයා හිතන්න ඕන විදිහ ඔයාට තේරෙනවා. right? So ඉතින් මේක හොඳට ඔය වැඩේ කරන්න ඕනේ අපි වැඩේ කොට දාන්න. හරිද? දැන් papers කවදාවත් miss කරන්න එපා කොහොම හරි ලියන්න. ලියලා අපි ඒකේ marks evaluate කරගෙන යන්න ඕනේ මොනවද ඔයාගේ. එතකොට හැම වෙලේම ඔක වැඩි වෙවීම යන්නේ නැහැ ළමයි. දැන් හිතන්න last term එකේ වාට හොඳට marks තියෙන්න. but මේ term එකේ පොඩ්ඩක් ලකුණු අඩු වෙන්න පුළුවන්. එහෙම තමයි. හරිද? ඔක්කොම එක විදිහටම ඉන්ක්‍රීස් වෙවි යන්නේ නැහැ. හරි ඒ හින්දා ඒකත් ඇක්සෙප්ට් කරන්න. අඩු වැඩි වෙන්න පුළුවන්. වැඩි වුණාම ගොඩාක් සතුටු වෙන්නත් හොඳ නැහැ. අඩු වුණාම ගොඩාක් දුක් වෙන්නත් හොඳ නැහැ. හැම එකක්ම මැද ඉඳන් බලන්න. So always try to do everything that is possible for you to increase your mark. ලකුණු වැඩි කරගන්න පුළුවන් හැමදේම කරන්න. හරි සමහර වෙලාවට මේව අපිට නිකන් තේරෙන්නෙත් නැහැ මේකේ ඉම්ප්‍රූව්මන්ට් එකක් තියෙනවා කියලා. බට් අපි ඒක දිගටම කරගෙන යන්න ඕන. හරි අපි කියන අල්ලගෙන ඉන්න ඕනේ කියලා අන්න ඒක තමයි කියන කතන්දර. හරි ඉතින් අර දැන් ඔයාලට ඉස්සරහට ස්ටාර්ට් කරන්න දෙන ඕගැනික් කෙමිස්ට්‍රි. හරි දැන් පොඩි ඩිලේ එකක් තිබ්බා මේ මාසේ ඉනෝගැනික් වල පොඩි අන්තිම පාර්ට් එකේ ඉඳලා. ඒකත් ඉවර වෙනවා. Then we can peacefully start the organic chemistry from the end of this month. හරි එතකොට එතන ඉඳන් ඔයාලට වෙන්නේ ආවගේ ඔය කෙමිස්ට්‍රි වල වෙනම chapter එකක් යනවා. හරිද? එතකොට ඒ ටික ලස්සනට කරගෙන යන්න. ඒ අතරේ අපි මෙහෙම monthly test වලින් ඔය පොඩි පොඩි paper අපි කොහොමද class එකේ කරනවානේ. ඒ වෙන් ඔය පරණ ටික හොඳට මතක් කරගන්න. හරිද? ඒකයි වෙන්න ඕනේ. ස්කූල්ස් වල යන ළමයි ටර්ම් ටෙස්ට් අනිවාර්යෙන් යාළගේ ස්කූල්ස් වලට ගිහිල්ලා ලියන්න. ඒක අමාරු ලේසි වෙන්න පුළුවන්. it's okay. ඔයා ලියන එක තමයි එතන කරන්න ඕනේ. හරි අනිවාර්යෙන් මගේ ටෙස්ට් එකටත් ඇවිල්ලා ලියන්න. තේරුණා නේද? මගේ ටෙස්ට් එකෙන් ඉවැලුවේට් කරගන්න what will you get when you go to the exam. දැන් ආයෙත් එක්සෑම් පේපර් එක වගේ එකක් නේ මම දෙන්නේ. පොඩ්ඩක් ඉරට අමාරුයි. ඉතින් ඒ වගේ එකම හිතාගන්න කොහොමද ඔයාලට එක්සෑම් එකට ගියා නම් හම්බෙන මාක්ස් කියලා. හරිද? දැන් ස්කූල් එකත් ලියන්න, මගේ එකත් ලියන්න. දෙකෙන්ම බලන්න මොනවද ඔයාලට බැරි කියලා. ඒ ටික හදාගන්න. මගේ පේපරෙන් පොඩි ඉවැලුවේෂන් එකක් කරගන්න එක්සෑම් එකට කොහොමද තව මොනවද කොච්චරක් වගේ හම්බෙයිද කියලා අර පොඩි ක්ලෝස් ගතියක් තියෙන එක්සෑම් එකත් එක්ක අපේ පේපර්ස්. හරි ඒක අනිවාර්යෙන් කරන්න. So this is how you get the answer for the first structured essay. Sorry, second structured essay first part. Clear නේද? ඔයාලා අහන්නේ මොනවද? Identifying the compounds, balancing the chemical equations, those things. I'll show you the marking scheme in a minute. But before that, let's finish the remaining sub questions also. 3, 4, 5, 6 කියලා තව question හතරක් තියෙනවා. ඒ ටිකටත් මම answer ගන්න හැටි කියන්න නැත්නම් මට පුළුවන් ඔක marking එකේ පෙන්නන්න. Shall I show you it in the marking? It will be better, ne? Can save some time. Now the marking of this question is this one. මේ තියෙන්නේ ඔකේ marking එක. Answers are there. දැන් මම තව දෙයක් කළා මේ වෙනා marking the papers. I didn't consider the order of the reactions. Now lithium nitrate next. හිතන්නකො ළමයට පළවෙනි එකට marks නැති වෙන්න පුළුවන් identifying ABCD. But still if we write the proper reactions not in the given order but in the order that he selected, still if the reactions are balanced and if they are correct, then I gave marks. That's how happens in the exam also. හරිද? ඉතින් එහෙම marks දෙනවා. හැබැයි පුළුවන් තරම් බලන්න හරියටම කරන්න ඕනේ. Right, then what is the third question? Third, fourth, fifth and sixth questions are asking. So write a balanced equation for the reaction of water with the product obtained when the compound D is heated. Compound D is heated. Okay, so now they are telling now when you heat the compound B, you get barium oxide. So they are asking you to write the reaction of that product, barium oxide, with water. Okay, so we already wrote that one and it is anyway balanced. Okay, so read the question carefully. Okay, and then they ask in the next question, fourth one, write a balanced equation for the reaction of N2 with the metallic element that contribute to form A. A is lithium nitrate. No? So they are asking the reaction between lithium metal. Now the metal contribute to form lithium nitrate is lithium. So they are asking the reaction between lithium and N2. Lithium and N2. So you can see the reaction. I said earlier also this lithium is similar to group 2 reactions. Group 2 elements and lithium can react with N2 to form lithium nitride or the metal nitride. Okay, Li3N. Right, so it is formed and you have to balance that one. So I saw some of you had a difficulty of getting the formula also. Then lithium nitrate ලියන්න ගිහිල්ලා වරද්ද ගත්තාත් මම දැක්කා. හරිද? දැන් මම පොඩක් පොඩි උදව්වක් කරන්න. Now if it is lithium nitrate, lithium take the lithium charge පුතේ. Li plus නේ. Then NO3 it is sorry nitride it is N3 minus. හරිද? ඔයා හිතන්න ප්ලස් වලින් මයිනස් එක කැන්සල් කරන්න ඕනේ. You did the same thing in O levels by getting the valencies as cross and crossing them. But then එච්චරම යන්න ඕනේ නැහැ නිකන් හිතන්න. Then you will be needing 3 lithium ions නේ. Li3n. Is that clear? Li3n. මොනවද තමයි එන්නේ? lithium nitride. Li3n. ඒක හරියට ලියන්න ඕනේ. ඕක ලියාගත්තොත් තමයි ඊළඟ ගන්න පුළුවන්. Because lithium reacts with N2 to form Li3n. Then you can balance it. Putting 6 lithium to 6 lithium and N2 forms Li3n. ගන්න පුළුවන්. මේ දෙක හරියටම ලියන්න අර ඒ වගේව පටල ගන්න එපා. බැලන්ස් කරන ඒවා කරන්න ඕනේ. Without balancing you will not get any marks. ලකුණු නැහැ පුතේ බැලන්ස් කරේ නැත්තම්. ඒවා එමෙට හදාගන්න. And then it is asking in the fifth question, what are the products it will give you when that lithium nitride, lithium nitride, you have to say it properly, lithium nitride Li3n, when it is reacted with water. Okay, so we kind of memorize this one from the unit 6 S block ne. S block එකේදී මේවා හොඳට memorize කරා ඔයගොල්ලෝ. Li3n will give you lithium hydroxide and N2 and ammonia. Lithium hydroxide and ammonia. So it is giving you a gas that can turn red litmus into blue. මතකද? Nessler's reagent into brown, like that. So here the gas is NH3. And more importantly, lamai, you must balance this only. Without balancing, don't expect marks. Then look at the sixth one. Write a chemical test to identify colorless gas evolved in the test tube B. Test tube B contains magnesium carbonate. So when you thermal decompose magnesium carbonate, you are getting carbon dioxide. So they are asking a test to identify carbon dioxide. Okay, so don't mix it up. Test to identify carbon dioxide. So carbon dioxide can be identified by lime water testing. But just telling lime water test is not enough. The lime water test එක කියලා කියන්න එපා. Now here they are not asking you to name a test නේ දැන්. Okay, question එකේ අහන්නේ test එකක් නම ලියන්න කියලා නෙමෙයි. They are not asking you to name a test. They are asking you to write a test. When they are asking you to write a test, you need to describe the test. කියනවා මේක මෙහෙමයි test එක කරන්නේ. මෙහෙමයි observation එක කියලා කියන්න ඕන. නිකම්ම lime water test කියලා ලිව්වොත් you will have only few marks. Sometimes you will have no marks also. Right? So these are the points I checked. So you need to pass through a solution of calcium hydroxide, that is lime water. Then the solution turns to milky. On continued passing, තව කට්ටිය ලියලා තිබ්බ ළමයි අර milky වෙනවා කියලා නවත්තලා තිබ්බ. Some students were telling that solution lime water turns to milky and they stopped. But continue the test ළමයි. ඔක දිගටම කියන්න ඕන. After further passing, milky solution become colorless. You have to mention that too. ඔයා ඒකත් අනිවාර්යෙන් කියන්න ඕන. හරි නම් give the full test when they are asking you to identify carbon dioxide. Is that clear ළමයි? ඔයා මුළු full test එකම ලියන්න ඕන. හරි මම හිතනවා ඒක හොඳට clear ඇති කියලා. And that's how you should work on that area. කොහොමයි ඔය part එක කරන්නේ. හරිනේ එහෙනම් කට්ටිය. Right. Now ළමයි let's move into the next part. දැන් ඔය structure base එකේ part A එක. Now yeah, this is your part B. Now it's termed as part A by a mistake anyway. මේක තමයි ඔයාලගේ part B එක. And it is from D block. Okay, I'm going to discuss that too, but before that give me a minute ළමයි. And if you're having any doubts on the first part, please send them to our chat group. Chat එකට දාන්න මොනවා හරි doubt තියෙනවද? Okay. Right. Now look at this one පුතේ. හොඳේ. now බලන්න මේ Okay, so it is telling X is a D block element that belong to the fourth period of the periodic table. Now don't get confused ළමයි. දැන් fourth period of the periodic table කියන්නේ මොකක්ද? What is meant by fourth period of the periodic table? So that is those are the 3D elements. අර third 3D කට්ටිය ඉන්නේ fourth period එකේනේ. Right? So we call it as the 3D elements. 3D කට්ටිය ඔය ඉන්නේ. Right? So starting from what? Starting from scandium ඉඳන් scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. හරිද? You have these 10 elements. මේ 10 දෙනාම ඉන්නවා. ඔබ fourth period කියලාත් කියනවා. fourth period D block elements. So you can call them as 3D elements or first transition series. There are several names. Write those names. I'll tell again. Fourth period D block elements. Then you can call it as first transition period, or then you can call it them as 3D elements. Right? Then it is telling you on reacting this X with dilute HCl, a green color solution X1 and a gas X2 are obtained. So all these elements can react with HCl, but these are metals and HCl is an acid, no? So then acid and metal reaction will give you the metal salt, which will be the chloride of the metal, and it will give you definitely H2. So without knowing anything, you can just get the idea what is X2. X2 is going to be hydrogen. Because the metals and acids are reacting to give you hydrogen gas. H2 is hydrogen gas. Hydrogen gas. No need to put an upward arrow, but I am putting it here just to emphasize that is a gas. Right? Then look at the next sentence. When X1 is treated with, now X1 is the green color solution. And we can think about that too. Now, what are the things that are giving you green color solutions? Green solutions. Now, actually, these are green aqua complexes. Okay, aqua. So, which one is giving you aqua complexes? Green color. You can take Fe and nickel. Fe and nickel. No? So it may X may be Fe. Now actually it is ferrous. Okay, Fe2 plus ferrous hex aqua complex. Now ferric also having a hex aqua complex, but it is yellow brown. And the other one may be nickel hex aqua complex. So some students I saw they selected some random elements also. Some of these students selected chromium, some of them selected copper, but those are having kind of problems with the colors and everything. So the green color aqua complexes are given by ferrous and nickel. Okay, so you remember how we studied this one? 2 blue, 2 green, 2 pink, 1 yellow brown. That method we need to remember. Okay, so anyway, it's telling when X1 is treated with dilute ammonium hydroxide and ammonium chloride, and H2S was bubbled through the solution, thereafter a black precipitate X3 is obtained. Okay, so that X3 should be the sulfide. X3 should be the sulfide. So it is a black color sulfide. Okay, so ferrous sulfide is not there in our syllabus, but anyway, both these sulfides are black. Ferrous sulfide, nickel sulfide, both are black. Okay? So again, you can't decide which one it is. Okay, ferrous sulfide is not in the syllabus, but here just I'm telling you for the sake of question, it is black. Right? Then lamai, on addition of dilute sodium hydroxide, X1 give a green color precipitate, X4, and X4 did not dissolve in excess sodium hydroxide, and in excess ammonium dilute ammonium hydroxide, X4 dissolves, and that is the place where we can differentiate whether it is ferrous or nickel. Okay, put highlight that one if you have the paper. Hari, in excess dilute ammonium hydroxide, X4 dissolves. And a part එක highlight කරන්න. In excess ammonium hydroxide, X4 dissolves. And ඒක මාර important. Okay, that's how we decide the compound. Right? The මේගොල්ලෝ කියනවානේ මුලින්ම when you are passing when you are passing sodium hydroxide, දැන් හිතන්නකෝ මෙතන ඉන්නේ ferrous කියලා, right? With sodium hydroxide, it is going to give you ferrous hydroxide, which is a green color, dirty green precipitate. So when you add further NaOH, this one doesn't dissolve. Okay, so it is not dissolving since it is not amphotic. Since Fe2 plus, nickel 2 plus are not amphotic. That's why they don't dissolve in NaOH. So you know, if they dissolve like aluminium, zinc වගේ කෙනෙක් නම් මෙයා dissolve වෙනවනේ. That means aluminium, zinc are amphoteric. Okay, so here it is not dissolving, that means it is not amphoteric. You can say it is not zinc. Anyway, we eliminated that. If it is nickel, it's going to give you nickel hydroxide, which is green color, and same thing will happen. It will not dissolve in excess sodium hydroxide. But the story changes when you go for the reactions of these two ions with ammonium hydroxide. So when you add ammonium hydroxide, ferrous will give you ferrous hydroxide, just like earlier, a dirty green precipitate. But when you add further ammonium hydroxide, it is not going to get dissolved. Okay. But if you take nickel, I hope you remember this part. It is going to give you nickel hydroxide, the same green color precipitate it is given, it gave earlier. And with further ammonium hydroxide, it is going to give you an amine complex. Amine complex. So amine complex is having 6 amine ligands, and the charge would be 2 plus. And this is an aqueous solution, a blue color, a deep blue, or you can say dark blue, aqueous complex. Understand? So this ferrous hydroxide couldn't dissolve because ferrous is not making any amine complexes. That's why it couldn't dissolve. Understood, Pudi? So it should be this one, no? Nickel. Get the idea now? That's how you decide which compound, which one it is. So then your X will be nickel, right? And then you can quickly write, no? X1 is H2, X2 we'll see, X3 is nickel hydroxide. So nickel sulfide. Understood. So like that you can continue filling. Now the problem I know that you had is identifying whether it is nickel or ferrous. And I should say most of the students did this one correctly. ගොඩක් අය මේක කරලා තිබුණා. සමහර අයට ඔක හිර වෙලා තිබ්බ මේක ගන්නෙ කොහොමද කියලා. ඕකේ ළමයි? Right, so what is that X1? X1 is the green color solution. දැන් මේක ඔයාට එක එක ඒවා ලියන්න පුළුවන්. හරිද? You can write it like nickel chloride since it is reacted with HCl, or you can call it as the nickel hexaqua complex. Anything you prefer. But don't just say nickel, that is not that appropriate. Okay? Then what is X4? X4 is the green precipitate that it formed. This one is X4. And then it is telling X4 did not dissolve in excess dilute NaOH. In excess dilute sodium hydroxide, X4 dissolves to give X5. Now this is also X4, and this one will be X5. Nickel amine complex. Remember, there you have 6 amine ligands on it. Then with excess on treatment of solution containing X1 with conc HCl. Then කලින් ළමයි dilute HCl දැම්ම කියලා amine complex මේ chloride complexes හැදෙන්නේ. It just give you the aqua complex. If you want the chloride complex, you should add either excess diluted Cl or it should say adding concave Cl. Concave Cl දානවා කියන්නේ කිව්වත් කමක් නැහැ. So then this aqua complex will give you the tetrachloride complex ne? NiCl4 2 minus. We will give that complex. All chloride complex that we study are tetrachloride. Understood? So that's how you get the x1 to x6. And then it is asking electronic configuration, IUPAC names. I'll show you the answers to get a rough idea about them. So these are your answers that you can see. And when you are writing the electronic configuration, I noticed only one student wrote argon times like that. So no marks for that one. You should write the full configuration. Now the argon times එක නම් එයාලා ඉල්ලන්නේ එයාලා කියනවා condense configuration දෙන්න කියලා. Now here they are not asking you for the condense configuration. So you can't write that argon times whatever. Okay. Right, and the IUPAC names also I noticed some problems of you. Don't start with capital letters. If you started, that one is wrong. And then don't leave any spaces between hexaamine and nickel. That is also wrong. And use Roman capitals to indicate the oxidation number. And please write iron. So without iron, again, that is wrong. So my point is, Lama, you should write exactly like this. Maybe දිහටම ලියන්න ඕනේ ලකුණු ගන්න. Use all the simple letters. හරි ඒ වගේ ලියන්න. ඔය hexaamine කියද්දී A අකුරු දෙකයි M අකුරු දෙකයි. You need to pay attention for those small details too. And I hope you understood pretty well. So that's how it is going for the first structure DC. Sorry, second structure DC. Okay, Lama? Right. Now let's go to the third question. I mean the essay question. So what I wanted you to mainly explain this structured essay question, because it is we are nowadays completing the inorganic. So get an idea about what are the things we should again study. දැන් මේවා papers කරන්න ළමයි අපේ අඩුපාඩු හදාගන්නනේ. ඉතින් refer කරන්න ඔය අහුවෙච්ච points ටික හොඳේ. Now look at this question. This question. The part A is from energetics and part B is from gases. Okay, we'll discuss that. In part A, lamani, now they are asking you to find a certain enthalpy change. So I'll do it in the board and show you. They are asking you to find a certain enthalpy change. They are asking you to find a certain enthalpy change. Now what is the enthalpy change? They are asking you to find formation enthalpy of NO2. Delta H standard F NO2. Okay. So then they have given you two data. What are the two data? NO plus half O2 goes to NO2. The enthalpy change is minus 57. And then again they have given half N2 plus O2 goes to, sorry, half N2 and half O2 goes to NO. So it is a positive formation enthalpy change. Right? So I'll tell you about these details anyway in a minute. Now Lamai, they are asking you to find this formation enthalpy. So what we should do, we should write a first of all reaction. Then make a reaction එකක් ලියන්න. Okay. In formation enthalpy we have a definition. Remind that definition. If you don't remember that definition, you must write that one in your review. හොඳේ. දැන් හිතන්න පාඩ මේ සමහර definition එක මතක වෙන්න පුළුවන්. මතක නැහැ අපි මම පොඩ පල්ලෙහාම හිතලා කියන්නේ. Formation enthalpy අමතක වෙන්නේ නැහැ ළමයට. අපි හිතමු නිකන් එහෙම එක්කෙනෙක් ඉන්නවා කියලා. ඒතර මොකද්ද කරන්න ඕනේ? Formation definition එක උතන ලියන්න ඕනේ. ඒතර ආ ඒක refer කරනවානේ. මුකුත් නොලියා මේකේ review එක විතරක් ලිව්වා කියලා වැඩක් නැහැ. හරිද පුතේ? So write the මතක වුණත් නැති වුණත් කොහොම හරි ලියන්න definition. It will help you to make your connections in the brain proper. Right? So what is the formation enthalpy definition? It tells you that we are going to form a certain compound starting from the reference elements of that reference forms of that element. Now to make NO2, we are going to make 1 mole of NO2. 1 mole of NO2. To form that, we need the elements nitrogen and oxygen. We need one nitrogen atom, but the reference form of nitrogen is N2 gas. N2 gas. So you are taking half N2 gas, and then you are taking full O2 gas. This is the formation enthalpy of NO2. So this is the enthalpy change that we need to find. Let's label it as delta H3. This is the value we need to find. Understand? But to find the answer for this question lama, you have multiple methods. You can change equations and do this question, and there are many ways. But here we are specifically expecting you to draw a thermochemical cycle. Then you must follow that advice. Cycle එකක්ම ඔයාලා අඳින්න ඕන. So how do we make a cycle for this one? අපි මේකට cycle එකක් කොහොමද හදාගන්නේ? That may be a doubt that you are having. Cycle එකක් හදාගන්නේ කියලා. Start from somewhere common. Now can you see NO2 are common? එහෙනම් මෙයත් හදන්නේ NO2 ම තමයි. Starting from NO and half O2. So එයාගේ enthalpy change එක මෙතෙන්ට දාන්න. Delta H, let's say it is delta H1 minus 57. Here it is delta H3. This is what we need to find. Right? Then lamai, there was a logic in our thermochemical cycles. When you have 3 equations, if you put 2 properly, third one should come automatically. Then automatically NO. Right? And then next one, we can use this equation. NO එකක් හදනවා. Yeah, so it is plus 90. We'll call it as delta H2 plus 9. Both multiply කරන්න නම් මනම් කරන්න නෑ ළම ඔය විදියටම ගන්න තියෙන්නේ. But you may have a doubt here. Now here is half O2, half N2. Half N2 is there, but here you have O2. හරිද? ඔය O2 එකෙන් ළමයි ඔක්කොම consume වෙන්නේ නැහැ. Only half is consumed from this O2. The remaining half, the half is consumed to form NO, and the remaining half is still here. Either this is a balanced thermochemical cycle. දැන් ඔයාගේ මේ cycle එක balance වුණාත් ළමයි ආයෙමත් ලකුණු කැපෙනවා. හරිද? So we must mention physical state and we must indicate the relevant enthalpy changes. Then once we are applying Hess's law එක කියන්නේ මොකද්ද? මේ part එක equal මේකට equal. Okay, this is where the arrows are starting and this is where the arrows are finishing. So we can say according to Hess's law, delta H3 is equal to delta H1 plus 2. Then substitute the values and get your answer. Answer will be a positive answer. Plus, so minus 57 plus 90. Okay, so you will get positive 33. Then ළමයින්ට තව පැටලුණ තැනක් තියෙනවා. මේවා units එහෙම දාන්න ඕනේ. I'll show you the units and proper marking scheme. දැන් තව ළමයින්ට පැටලුණ තැනක් තිබුණා. මේ මම අහුවා එක්කෙනෙක් ඇවිල්ලා. දැන් formation enthalpy positive වෙන්න පුළුවන්ද කියලා අහනවා. In formation enthalpy can be positive and negative both ළමයි. So what is the meaning of it being positive? Positive වෙන එකේ තේරුම මොකක්ද? Its product is having higher enthalpy than its reactant reference elements. The reference elements වලට වඩා unstable කෙනෙක් නම් තමයි formation positive වෙන්නේ. හරිද? The reference වලට වඩා stable කෙනෙක් ඉන්නවා කියලා හිතන්නකො. ගොඩක් ඉන්නේ එහෙම අයනේ. නැත්නම් nature එකේ compounds හැදෙන්නේ නැහැනේ ළමයි. Compound හැදෙන්නේ nature එකේ because those compounds are more stable than the elements. Elements වලට වඩා stable හින්දා තමයි compounds හැදෙන්නේ. Elements are වඩා compounds are stable. එහෙනම් that's why most of the formation enthalpies are negative. But you will get positive formation enthalpy changes too. ඒතර මේක positive වෙන්න පුළුවන්. issue එකක් නෑ. ඔය nitrogen ගේ oxide ගොඩක් කියලා positive වෙන්නේ. මොකද N2 and O2 හොඳයිනේ ළමයි. යාලා stable gases. Now I hope you got the idea about that one. So that's how you figure out the answer for the first part. and then using that first part answer, you are asked to find the enthalpy change of this reaction. දැන් යාර පළවෙනි එකේ ගත්ත answer එක use කරලා ඔයාලට තව question එකක් කරන්න කියලා කියනවා. Okay, I'll show you the answer of the first one. අපි ඉස්සෙල්ලා බලමු. Answer of the first one is this. Then මෙන්න මේ cycle එක දෙන්න. clear නේ? මෙහෙම answer එක දෙන්න ඕනේ මේ round කරලා තියෙන marks දෙද්දි බලපු එක. දැන් හිතන්න ඔය එකක් හරි balance නැහැ කියලා. So you will lose that mark. So overall 12 marks were given for the cycle. දැන් ඔයා වෙන method එකකට මේක හදන්න ගියා නම් ඔයාට ඔය 12 marks හම්බෙන්නේ නැහැ. Some students were doing equation addition method. අර equation හරවලා add කරන method එක. ඒතර ඒකට ඔය 12 mark loss වෙනවා. You will have one marks for the correct answer, but for the method you will lose some marks. Okay, Lama? Now look at the next thermochemical cycle. දැන් මේකටත් ඔයාලට thermochemical cycle එකක් හදන්න පුළුවන්. හරි මම පොඩ්ඩක් question එක ඉස්සෙල්ලා කතා කරලා ඉන්නම්. Be valuable for you. මේ discussions මම පොඩ්ඩක් අද වෙලාව ආරම්භ මේක කරනවා. brief කියලා හිතලා පටන් ගත්තට මට මේක කරන් යද්දි ළමයි එහෙම පොඩට කියන්න හිතෙන්නේ නැහැ. So I know some students are there that are struggling. ඒක යාළුවා පවුනේ. දැන් මේක දැන් මෙතන මීටින් එකේ ඉන්න අයට මං හිතන්නේ එහෙම ලොකු issues නැහැ. හරි but එහෙම set එකක් ඉන්නවා ඉතින් නේ. යාළුවා ගැනත් බලන්න ඕනේ. So I'm going to tell you the other part also. Listen. හරි. Now using that enthalpy change you found, NO2 formation enthalpy, you need to find out the enthalpy change of this reaction. Reaction එකක් අලුතෙන් දීලා තියෙනවා. 2NO2 half O2 and water is giving you 2HNO3. HNO3 දෙකක් දෙනවා කියන ඔන්න ඔය reaction එක. හරිද? ඒතර ළමයි මේ formations නේ දීලා තියෙන්නේ. And when we have formation enthalpies, we have this short method. You can draw a cycle very easily starting from the reference elements. එක පැත්තක් දිහා බලාගෙන reference elements ලියන්න. H2 gas, N2 gas and 3O2 gas. මම මේ පැත්ත බලාගෙන ලියුවා. It is easy. So here we are forming 2 times nitric acids. අර 2 එහෙම අමතක වෙලා තිබ්බ කට්ටියට. So formation enthalpy of HNO3 into 2. The value එක දාලා ඒක into 2 දාන්න. හරි. Then look at this one. Then the found value for the formation of NO2. You can use that one. NO2 එකත් into 2 because there are 2 NO2s නේ. දැන් O2 ට O2 එහෙම හදන්න එකක් නැහැ. Don't put any arrow. But for this one, other thing, water. එතනත් formation enthalpy of water. So then the Hess cycle will be this part is equal to this one. Okay, so then this unknown enthalpy, let's say it is delta H, you can find it by applying the Hess's law. නැත්තම් ඕකම ආයෙ ඔයගලන්ට ඕනනම් හදන්න පුළුවන් ළමයි අර මේ ෆෝමියුලා එකනොත්. මොකද මේකේ method එකක් specify කරලා නැහැ. Here there's no method is specified, okay, in this question. So you can try that one using equation method also. Equation method also. Right? So delta H naught Rxn sigma delta H naught formation of products minus sigma delta H naught formation of reactants. මෙන්න මෙහෙම දාන්න ඕනේ. දැන් වෙන වෙන ඒවා ලිව්වට ලකුණු දෙන්නේ නැහැ ළමයි. sigma sign එක තියෙන්න ඕනේ, formation තියෙන්න ඕනේ. So I saw some students are writing delta H delta H products. එහෙම ලියන්න එපා. delta H products කියලා එකක් නැහැ. It should be formation. F must be there. ඔය දාලා ලියන්න නැත්නම් ඔය formula එකකට ලකුණු නැති වෙනවා. ලකුණු නැති වෙන්න තමයි තියෙන්නේ මුළු paper එකෙම නේද? ඒක අපි තේරුම් අරන් හරියට කරන්න ඕනේ. Okay, so after using that values, formation values, you can find out the enthalpy change. Enthalpy change. for this one. Right, now we will go to the marking scheme and see පුතේ. Marking scheme එකට ගිහින් බලමු. So මේ තියෙන එකට මම methods දෙකක් දුන්නා. One is the formation thermochemical cycle and the other one is using equation method. Method දෙකම හරි. And you can understand නේ අර value දාලා ලියන්නත් පුළුවන්. Or you can put single arrow also නේ. මම මේ approach එකත් ගත්තා. So nowadays that's the actually the more appropriate method. Don't put multiple arrows like this. I mean arrow දෙකක් දානකොට දාලම එක arrow එකක් දාන්න. In that single arrow you can write both NO2 and water. water ට කොහොමත් එකක් නැහැ. ඒ arrow එක උඩ ඉන්න කට්ටිය add කර කර ලියන්න. Now can you see? I added them with a plus sign. This approach is also better. And then you will get 9 minus 95 as the enthalpy change. මේකත් මේ විදිහට දාලා ගන්න පුළුවන්. Okay. And not only enthalpy change පුතේ, they are asking for the entropy change also නේ. So entropy එකටත් අර තියෙන formula එක ලියන්න. And then there's a special point regarding the entropy. Now can you see I use the formula with delta F. Delta S standard F. Delta. හරි ඒතර ඔය හැම වෙලෙම delta එන්නේ නැහැ. දැන් මේකේ ඔහොම ආවට but I'll show you it with the question. In the question පුතේ can you see the data? It is delta S not F. And sometimes they are giving you delta S. Sorry, S not කියලා කෙලින්ම දෙනවා. කියන්නේ entropy එක දෙනවා. දැන් මේ දේ තියෙන formation entropy change එකනේ. එහෙම නෙමෙයි කෙලින්ම entropy එක දෙන්නත් පුළුවන්. Entropy can be found exactly. නේද? කෙලින්ම entropy එක දෙන්නත් පුළුවන්. එහෙම දුන්නොත් ඔයාගේ formula එක වෙන්න ඕනේ delta S not is equal to F or something is equal to sigma no delta sign S naught products minus sigma S naught reactants. අන්න sigma sign එකයි delta sign එක නැහැලම. දැන් මෙතන අපිට delta sign එක දාන්න වෙනවා. මොකද මේකේ question එකේ එක දීලා තියෙනවා මේ formation entropy changes කියලා. හරිද? the enthalpy gives energy වගේ තමයි ඕනම එකක් formation අපිට දාන්න පුළුවන්. entropy ත් එහෙම. formation reaction එකේ entropy change. දැන් ඔයා දැක්කනේ NO2 හැදෙන්නේ N2 and half O2 වලින් කියලා. now you earlier saw N2 and O2 are formed sorry N2 and O2 are joined to form NO2 නේ. හරි? NO2 නේ. මේ ඒතර ඒ reaction එකේ entropy change එක තමයි ඔය දීලා තියෙන්නේ. 240. Try to understand that. Right, so anyway from that after that you can go to the delta G finding also. එවනම් දැන් කට්ටිය කරනවා හොඳයි. දැන් delta G එහෙම හොයනකොට ළමයි මොකද කරන්න ඕන? දැන් ඔයාගේ unit එක ගැන concern වෙන්න ඕනේ. delta G delta S is given by joule per mole නේ. ඒ හින්දා joule per mole per kelvin නේ. ඔයා එක 1000 වලින් divide කරලා kilojoule per mole per kelvin වලට convert කරනවා. හරි? And තව දෙයක් when you are writing this delta G naught formula ඔයාගේ G naught not sign එක දැම්මේ නැත්නම් ආයෙ වැරදි. හරිද? හරියටම ලියන්න ඕන. මම ලකුණු කැපුවා කාටවත් ලකුණු දුන්නේ නැහැ. note එකක් හරි නැතුව ලියුවා. ඒ හිතන්නකෝ නිකම්ම ලියනවා delta G delta equal delta H minus T delta S කියලා ලිව්වොත් marks නැහැ. You should put that not sign. මොකද these values are standard values. So we are applying the standard equation to find the answer. වෙනේවා ලියලා හරියන්නේ. Okay, I hope it is clear. Now finally පුතේ they are asking you for a comment about the spontaneity of the reaction. මේ reaction එක automatically වෙයිද නැද්ද කියලා ඔයගොල්ලන්ගෙන් comment එකක් අහනවා. So it all depends on your answer. If you get a negative answer like we do, that means the reaction is spontaneous. So you can comment on that. Okay? When you are writing also, now these things you are doing normally, say since the reaction delta G is negative, this reaction is spontaneous. That's how you are telling the answer. Okay Lamai, so I hope it is clear. Now I'll show you the second part of this question. It is from gases වලින් අහපු part එකකුත් තියෙනවා. I'll give you a small short note about the question in the board. I පොඩ්ඩක් ඒකත් අහගන්න. Initially at 127 Celsius certain amount of N2O5. දැන් N2O5 වලින් certain amount එකක් තියෙනවලු 4.157 mil decimeter cube නේ. decimeter cube container එක at 127 Celsius, and they are telling the pressure is 2.4 into 10 to the power 5 Newton per square meter. ඔක්කොම දීලා තියෙනවා. Now about this gas lamai, they have basically given you the volume, temperature, and pressure also. So only one thing that we don't know here, that is the number of moles of N2O5. So to find that one, we need to use PV equal nRT. So PV over RT. Then now that moles will be N2O5. Understand? Then they are telling you, Lamai, when you heat this one to 227. So when you heat this one to 227, will again it is a rigid vessel. So volume is not going to be changed. 4.157. සමහර වරද්ද ගත්තා volume එහෙම වෙනස් වෙනවා කියලා හිතලා තියෙනවා. ඒ අපි mistakes හදා ගන්න. Okay. Volume is 4.157, and now they are telling you the temperature. Temperature is given, 227 Celsius. We need to convert that into Kelvin before using it for a question. And then it says part of the N2O5 is decomposed to NO2 and O2. එහෙනම් මෙතනදී reaction එකක් වෙනවා. ඔය N2O5 වලින් කොටසක් ඔක්කොම නෙමෙයි. Part will be decomposed to NO2 and O2. NO2 and O2 වලට decompose වෙනවලු. So then we need to balance it 1, 2, 4 and O2. Make a balance. 10 oxygen atoms are there. So the ratios will be 2:4:1. A nice ratio for a question. The ratio එකක් ගන්නකට. And details, after partially decomposing, you found 0.2 N2O5 remaining. Now for that one, lamai, we are using our added reacted remaining method. Add කරපු ගාන මේකෙන් හොයාගන්න පුළුවන්. I'll show you it in the answers. ඒ ගානෙන් මෙයාලා හිටියේ නැහැ moles, and reacted ගාන ඔයාට ගන්න වෙනවා. But the remaining amount will be 0.2. 0.2 moles are remaining. ඉතින් ඔය react කරපු ගාන අල්ලගත්තොත් ළමයි we can find out the moles prepared by each gas නේ. මේ හැම gas එකකම හැදුන mole ගාන හොයන්න පුළුවන්. Okay, so that's how the question works. පොඩි සරල question එකක් හරියට ගත්තොත්. I saw most of you have tried this one. අර ගොඩක් අයට වෙන්නේ paper එක ලියද්දි timing අවුල් වෙනවා. ඒක පිස්සු නටනවා ඊට පස්සේ වෙන මේවා ලියනවා. So I think එමෙට හදා ගන්න ඕන paper කරලම තමයි හදන්න වෙන්නේ. Later, බය වෙන්න එපා මම කියන ටික කරා. Right, then find the moles of N2O5. Like I said, we need to apply PV equal nRT for that one. And find the total moles of gases present at 227 Celsius after decomposition is complete. For that, I think we need the number of moles of N2O5. අපොඩ එකට ගිහින් බලමු. marking එකේ. How many moles of N2O5 was there? 0.3. දැන් මේ බලන්න මේකේ substitution එක ඔය විදිහටම කරන්න ඕනේ. දැන් ගොඩක් කීප දෙනෙක් මම දැක්කා volume එක convert කරගන්න බැරුව හිටියා. So when they are giving you the volume in decimeter cube පුතේ, you can't apply that value as it is. Volume must be converted to meter cube. Meter cube වලට convert කරන්න ඕනේ. නැත්නම් ඔක දාන්න බෑ. clear නේද? Volume must be converted to meter cube. හරි, දැන් හිතන්නකෝ initially you had 0.3 නේ. Look at this table, how we use the, and you need to substitute units also. The units නැතියට මේ 2 marks නෑ හොඳ. Right. කොහොම වැරදි හදාගන්න මම ඉතින් ඒක තමයි බර දාලා කියන්නේ. Right, now they says only 0.2 is remaining. So you can now understand 0.1 has reacted. That means in this side දැන් හිතන්නකෝ මෙතන 2 react කරොත් 4 1 හැදෙනවනේ. 1 react කරොත් කොච්චරද හැදෙන්නේ? 1 react කරොත් 2 and 0.5. එහෙනම් 0.1 react කරොත් මෙතන හැදෙනවා 0.2 and 0.05. Like that අර ratios use කරන්න. We should be kind of clever to do that one. ගොඩක් අය කරලා තිබ්බා හොඳ. 0.2 and 0.05. So how many Total moles are there. 0.45 moles were there. That is second question answer. Then when you go to the third question, I think they are asking for the pressure. When you make a pressure, so how do we get the pressure? Again, we are using PV equal nRT. Now it is nRT over V. දැන් මම මේ මෝල් ගාන දන්නවනේ. මොක දාලා ටෙම්පරේචර් දාලා හදන්න තියෙන්නේ. ඕකේ. ගොඩක් අය කරලා තිබුණා හොඳයි. බට් සමහර අය මම මේ දැක්ක හිර වෙලා තියෙන. එයාලා මේ වීඩියෝ එක බලනවා නම් එයාලට පන්ති ඉන්නවා නම් ඒව ටික අනිවාර්යෙන් හදා ගන්න ඕනේ. අපිට බැරි දේවල් නෑ මේවා අපිට අහුවෙච්ච නැති ප්‍රශ්න තියෙන්නේ. ප්‍රැක්ටිස් කරලා මදිකම. ඒක දැන් මේ questions එක කරන්න. Now see the method I added there, the RR method. I gave 6 marks for balancing equation also. Equation එක balance කරනවලත් පුතේ ලකුණු දීලා තියෙනවා. ඒවා හදාගන්න. And there's an alternative method. මම අර sentences method එකක් දුන්නා. I'll show you that part. මෙතන මෙන්න මෙහෙම ලියන්නත් පුළුවන්. Reacted moles, you can find out how many moles reacted by simply subtracting this. ඊට පස්සේ ඒක අර formed moles වලට යන්න තියෙනවා. Both are still the same. හරිද? ඒක කිසිම අවුලක් නෑ. හරි. ඊට කළොතින් ඔය විදිහටත් marks දුන්නා. I saw some of the students had tried this method. මේක සමහර අය try කරපු අයත් ඉන්නවා. And this is how you are applying the PV equal nRT for the third part. හරිද? ඊට පස්සේ ළමයි fourth part එකේ මොනවද යාලා අහන්නේ? Go to the question and see. In the fourth part, they are asking after finding the total pressure, they are asking for the partial pressures of each gas. මේ හැම gas එකකම N2O5 ඉතුරු වෙච්ච ටිකේ NO2 NO2 හැදිච්ච ටිකේ partial pressures අහනවා. ඒතරදී ඔකට හොඳම ළමයි Dalton law එක apply කරන එක. Dalton's law of partial pressure. He said that the total pressure is given by the addition of individual pressures of individual gases. හරිද? වෙන වෙනම add කරන්න කියලා කියනවා. So N2O5, NO2, NO2 එයාලගේ pressures හොයාගෙන add කරන්න partial pressures හොයාගෙන. Okay, then I'll show you how to find the partial pressure with the marking scheme. යෙන්ටි කොළුවට ගන්න ළමයි ඇති. ඉතින් find the mole fraction, then multiply by the total pressure. Find the mole fraction, then multiply by the total pressure. ඉතින් මේ වගේ methods use කරන්න when you are doing questions. කොහේ හරි logically අවුලක් ගිහින් තිබ්බනම් ඒක දැන් මෙතන discussion එකෙන් කතා කරමු. Okay ළමයි, so that's how the third essay question finishes. Okay, this month's test also you will be having kind of similar questions on the energetics, gases එකම දාන්න. Right. Now let's go to the next part. Next part is about ළමයි the inorganic essay question. Inorganic වලින් මේ සැරේ essay එකක් තනි එකක් දාලා තිබ්බා. And the first part is coming from inorganic analysis. Analysis වල cation group analysis කියලා එකක් තිබ්බේ. ඒකෙන් තමයි ඔක අහලා තිබ්බේ. හරි, ඉතින් ඔක අපි ආයෙ වෙලාවක හොතර මතක් කරගමු ඊළඟ question discussion එකකදී. So anyway, I'll tell you briefly the answers. ආසනස් ගන්න විදියට ටක් ගාලා කියාගෙන යන්න. හරි. It says an aqueous solution P contains 3 cations and 1 anion. 3 cations and 1 anion. Following experiments performs to identify these cations and anions. Okay, now let's see how did they identify cations. First of all, dilute HCl was added and there was a white precipitate was obtained. They labeled the white precipitate as Q. So what can be this Q? Q එන්න පුළුවන් කවුද? හොඳට හිතන්න. What can be this Q? When we add dilute HCl, that is group 1 of the cation group analysis. Group 1 of the cation group analysis. So Q can be Q can be AgCl, PbCl2 and Hg2Cl2 because all are white color chloride precipitates. The Q can be one of these three. Then look at the next one. The precipitate Q was filtered off and H2S was passed. Now you are passing H2S in the acidic medium. Now you are getting a black precipitate. This they haven't tell you anything, but this black PPT can be, it's a name එකක් දාලා නැහැ, but this black PPT can be ළමයි bismuth sulfide, copper sulfide, mercury sulfide, bismuth, copper, mercury and lead sulfide. Lead is partially precipitating in the first group ළමයි. The remaining part is precipitated in the next group. Lead is the only cation that precipitate in two groups. හරි අර මොකද පළවෙනි එක ඔක්කොම precipitated නැති හින්දා අනිත් හැමෝම selectively fully precipitated නම්. Now look at the third one. This is the precipitate obtained from the above filtration is filtered off and boiled. Now they are doing the group 4. So finally when we add ammonium chloride and ammonium hydroxide, it gives a green color precipitate. Here we don't have any doubt puthe, then R must be chromium hydroxide, the green color hydroxide. Okay, and then the fourth one, R filters out and precipitate was passed, H2S was passed and there was no observation. That means lamai we can say no, the fourth period sulfide precipitates. You can say no cobalt 2 plus, nickel 2 plus and you can say manganese 2 plus and zinc 2 plus. These cations cannot be there. If they were there, they will give you a precipitate without giving no observation. No observation කියලා දෙනවා කියන ළමයි මුකුත් හම්බෙන්නේ නැහැ කියන එකනේ. ඉතින් මෙන්න මේ cations හතර නැහැ in the fourth period. And fourth group නේ. cation group analysis එකේ fourth group එකේ මේ cation ටික එන්නේ නැහැ. ඒ cations හතරම නැහැ. Now look at the fifth one. When you add ammonium carbonate, a white precipitate is formed. That means our S can be magnesium carbonate, sorry not magnesium, calcium carbonate, strontium carbonate and barium carbonate. මේ තුනෙන් එකක් වෙන්න පුළුවන්. All these are white color. Right? So there will be tests to confirm this PQR, QRST, QRS with it. We will see. R is anyway confirmed now. So how do we identify Q? Look at this test. Water was added to the precipitate Q and boiled. Right? Then Q එකට water දාලා boil කරා. Okay. And it says the precipitate dissolved, but when it cooled, the white precipitate was formed again. අන්න ළමයි. boil කරද්දී dissolve වෙන්නේ කවුද? boil එකේදී dissolve වෙලා ආයෙ recrystallize වෙන්නේ. It should be PbCl2. PbCl, it will give you white color needle precipitates when it precipitated again. Q must be PbCl2. And the next one, H2O2, sorry, add more aqueous sodium hydroxide to the precipitate R. R is chromium hydroxide. And a green color solution was obtained. That means chromium, you can say chromium hexaqua complex or aqua complex, no matter hexaqua complex or hydroxide precipitate, it doesn't matter which compound it is. Anyway, they tells you are passing. Now earlier you got that one, or you got by adding ammonium chloride and ammonium hydroxide. Okay. So when you are adding aqueous NaOH, it is not going to dissolve. No, so it is dissolved and give you a green color solution. And we can suspect that one to be like using the green color. Yeah, that is chromium. Chromium hexa hydroxide complex, or you can simply tell it as uh, chromium's aqua complex. Okay, whatever. Right? So the next thing is the important thing. Pute, you are passing H2S gas, then yellowish solution is obtained, and from the green color you are identifying S. S is green color, so that means it is barium carbonate. So what's the reaction for this one? Let's take it as the chromium hexaqua complex, no? And is reacting with H2O2 and some NaOH will be remaining. In the basic medium, it's going to give you chromate, CrO4 2 minus. Now this one is yellow color. And there was an interesting reaction for this one, Lama. If you add acids, if you acidify this one, it will turn to dichromate. Remember, it will turn to dichromate. So this one is orange. It's very popular compound. And again, you can convert this back to chromate by adding basic medium. So that means chromate is stable in basic medium, while dichromate is stable in acidic medium. So you need to balance this one also using this redox method. Try to balance it. So now the method again. So anyway, now we identified the three cations. Cations come catayantically. Pb2 plus, chromium 3 plus, and finally barium 2 plus. Okay, so they're asking you for the formulae and reaction occur in the experiment 8. I'll show you that one, and what will be happening when we add dilute acids for that. And they're asking for the chemical reaction in 10 also. I didn't discuss that part. Let's go to that also, then we can see the answers at once. Right? Aluminium powder and aqueous NaOH was added to the P solution. Then gas with bitter odor was released. The gas filter paper soaked in Nestle's reagent. And that means that gas must be ammonia. Ammonia. So aluminium powder test. You can write that one. In that aluminium powder test, you are doing it to identify nitrates. NO3 minus. Then our anion must be that NO3 minus. Right? Because it is confirmed, Lama. You are doing brown ring test also. When in our theories, Lama, you remember, I said this theory part. It's kind of important. In aluminium powder testing, Al powder test, there are some other cations, the other anions that can answer this. Okay, in aluminium powder test, this is answered by NO3 minus, NO2 minus, and NH4 plus. And then brown ring test. Brown ring test is answered by nitrate, Br minus, and I minus. Now that's the importance of doing two tests together. Then if that anion gives positive observations for the both test, that means it must be nitrates. Okay, so that's how you identify cations and anions. Okay, so then in the last question they're asking you for a reaction bit for the 10th experiment. So I'll show you the reactions for this one. Okay, this is how the 75 marks were allocated. Okay, so then I'll show you how to balance this chromium thing also. Cr3 plus H2O2 reacts to form CrO4 2 minus, and now it is undergoing reduction to reduce to OH minus in basic medium. And I'll balance it and show you. I hope you understand the answers, right? Then first of all, Lamai, check the oxidation numbers. Plus 3, minus 1, plus 6, and here minus 2. Now there were 2 oxygen atoms, so minus 2 into 2, minus 4. Now here also you have 2 atoms, So cumulative oxidation number is -2. So now it is increasing oxidation number from +3 to +6 by losing 3 electrons. And here it is decreasing oxidation number by gaining 2 electrons. Now the least common multiple is 6, and here you have 2, 3, 2, and here you have 6. Then to check the charges, Lama, here this side you have -10, in this side you have +6. Okay, so to balance the charges, you are adding 16 H plus. Sorry, 16 OH minus. Then the both sides will have -10, -10. Then you can see this 6 OH and this one get cancelled. Then 10 OH will remain. And finally, you have to add water. You have 10 hydrogen, 16 hydrogen atoms. So you have 8 water. Understood? 8 water. So that's how you balance it using inspection. Sorry, redox method. ඕලම අමාරු නෑ. redox method එකෙන් සරස් දාලා balance කරලා ගන්න. Right? Some students were doing the balancing really good. And what I noticed mainly අර සමහරට මේක කරගන්න බැරි වෙලා තිබ්බා. I hope I think it is maybe due to the time. Time එක හින්දා වෙන්න පුළුවන්. So anyway, try to fix that error පුතේ. Now let's go to the next part. So there's an important thing I have for you to understand regarding this calculation. මේ calculation එක ගැන ළමයි important දෙයක් කියන්න තියෙනවා. So give me a few minutes to do it and finish our discussion. So what's that special thing about nitrate? So I mean the calculation. Okay, so here you have a solid mixture. You have a solid mixture containing FeC2O4, then FeSO4, and then sodium bicarbonate. Right? And was dissolved in water to prepare an aqueous solution of 250 centimeter cube. The following experiments are carried out with 325 centimeter portions. So you are putting that one in 250 centimeter cube container. Then for each experiment you are getting 25 centimeter small portions. Okay, in experiment 1, it is telling methyl orange against 2mH2SO4. You are titrating it with 2 mole per decimeter cube H2SO4, and since you added methyl orange, it will turn the color change, give the color change when burette reading is 25 centimeter cube. So now you need to think which one is reacting here exactly. reactions දීලා නැහැ. So now think how to understand. Here පුතේ it is reacting the bicarbonate anion with the basic can act as an acid too, and it is reacting with H plus to give you H2CO3. On my acid base reaction එක කරනවා. Okay, from that we can identify the sodium bicarbonate concentration. Bicarbonate concentration එක හොයලා දාන්න තියෙන එතන. ලොකු දෙයක්. Okay ළමයි. After writing the equation, I'll show you the answers. When experiment 1 එක moles of H2SO4 හොයන්න, then sodium bicarbonate will be twice like that. හරි, අර balance කරලා ඕනේ නේ ලියන්න. So I'll show you the marking මේ තියෙන ඉතුරු ටික balance කරලා ලියන්න. Na2SO4 and H2CO3. So 2:1 ratio නේ. එහෙනම් from the H2SO4 moles you can go to the sodium bicarbonate moles. එතනට යනවා. දැන් මේකේ interesting ම part එක ළමයි ඒක නෙමෙයි. මෙන්න මේ ඊළඟ part එක. Check this one. Second part. Now it says, not the second part actually, the third part. Okay? Give me a few minutes, I'll explain. Another 25 centimeter cube portion was acidified with HNO3 and excess barium chloride was added. Now you are getting a dry mass, another 25 cubic centimeter portion. So you will get the precipitate barium sulfate. Barium sulfate. So then they gave the mass of that one 2.33 grams. Okay, so if you divide this one by uh, mass divided by molar mass, you can find the number of moles. Then you can work back and get how much SO42 minus was there. Then moles of SO42 minus will be identical to moles of FeSO4. Understood? That's the way you are getting the barium hydroxide concentration. Okay, I'll show you the marking scheme of the second part also. Balance second part. Third reaction again. You're adding HNO3. Okay. Next, check the answers. Second part, barium sulfate moles. 0.01 moles are there. Okay. Right. Now, go to the next part, my last part of the question. What is it asking? Okay, it is asking the ferrous oxalate concentration. So there are two important things you need to note. I'll tell you the both points, lamai. Hari, then I'm making our 25 portion එකක් අරගෙන you are reacting that one with potassium dichromate. It's a good oxidizing agent. And now what are the things that are capable of oxidizing here? I mean, oxidize how? Now check that one. That's the important thing you need to figure out. Here we have Fe2 plus lamai. It will oxidize to Fe3 plus by giving you an electron. And here you have C2O42 minus also. Yath oxidize to give you 2 carbon dioxide. We got a double redox එකක්. දෙන්නම oxidize වෙනවා. And remember, Fe2 plus is coming from this also. Right. එහෙනම් ඔයාලා මොකද කරන්න තියෙන්නේ? You need to write two reactions for. You need to balance these two reactions. First of all, Fe2 plus and dichrome. Make a balance. It will give you Fe3 plus and 2Cr3 plus and water. Make one මතකයි balance එක. Here 1:6 ratio will be there. 6:1 ratio. කොහොම වෙනද බලන්න charges එහෙම balance කරන්න. We need to add 14H plus and 7 water. ඔන්න ඔහොම. 6:1 ratio. දැන් ඒතර මේ dichromate mole ගාන තියනවා ළමයා. Write it here. Moles of potassium dichromate you can find using its concentration and volume. Then from that moles, you need to subtract the reacted moles with Fe2 plus. Fe2 plus came from FeSO4 because you know FeSO4 moles, then subtract that. Then you will have the moles of K2CR2O7. That amount was reacted with Fe2SO4. Okay, we balanced it already. FeC2O4. Sorry. Okay, and find the number of moles of FeC2O4. Am I යන්න? Clear නේද ළමයි? That's the interesting thing for you to remember. හොඳට පාඩම් කරගන්න එක කොහොමද කරන්නේ කියලා. Okay, so I'll show you the marking scheme now. You can get a good idea from that. දැන් ඔන්න බලන්න. show you. මේ බලන්න එතන reactions ටිකින් experiment 3. ඉස්සෙල්ලම half ටික ලියන්න. ඕනනම් half නොලියා කෙලින්ම මම කොහොමද marks දුන්නේ final එකට විතරයි. You have a reaction between FeSO4 and K2Cr2O7. අර ඒක මම ලිව්වාගේ balance කරන්න. You can write chemical reactions by adding SO4 also. FeSO4 දැම්ම නම් හරි. Right? And then the next reaction, we can't forget the double redox. The open ළමයි පාඩම් කරගන්න ටික ටික. දැන් double redox එකේදී මෙයාට යන්නේ එහෙම කියලා මතක තියාගන්න. It's needed. So anyway, do this essay question, everyone. It's a very good one. None of you had done it correctly. කවුරුවත්ම මේක හරියට කරලා තිබුණේ නැහැ. මෙන්න මේක පොඩ්ඩක් advance වුණා because of I didn't give you the reactions. That's one thing. And another thing, it was FeSO4 was also reacting at the same time. ඒකත් ඔයාට ඕන. හරි. don't know why. then එන්නේ 2:1 ratio එකකින් එන්නේ for the double reduction. ඒකෙත් බලමු අපි answer එක ගන්න හැටි මේ බලන්න ළමයි. moles of dichromate you are finding and then FeSO4 වල තියෙන Fe2+ ටික හොයාගෙන ඒක අයින් කරන්න. okay 0.0167 තිබිලා තියෙනවා. you are subtracting that one. then you will get 0.01. that is the that is a dichromate reacted with FeC2O4. එහෙනම් ඒකේ ratio එකෙන් FeC2O4 mole ගන්න ගන්න. very simple. හොඳට බලන්න ඔය marking එක study කරන්න. do it really well and this is a very good essay question. හොඳම හොඳ essay එකක් ළමයි. for the calculations you can use this for your practice. ඉතින් clear the කට්ටිය රොන්නද කරපු ටික. we read a structured essay question and the two essays. මොකද අර basics ටික තමයි අන්තිමට essay වල කතා කරේ. and I'm telling again this calculation is very important. හොඳ calculation එකක්. ඒක කරන හැටි ඒ වගේ ප්‍රශ්න ටික හොඳ review එකක් හදන්න. ඉතින් ඔන්න අදින් paper discussion එක මෙතනින් ඉවර වෙනවා. April paper. and we didn't kept a test for the May June දෙකටම common test එකක් දැන් ඔන්න මේ weeks වල මම කරගෙන යනවා. ඒකේ හැම institute එකකම ළමයින්ට ඔබ ලියන්න පුළුවන්. so study. හොඳට study කරන්න ඔය ටික හොඳට බලාගන්න. will be helpful for your upcoming test. ඉතින් ඒ test එකත් අපි next week ඉඳන් හිමින් කතා කරගෙන යනවා. හරි නේද ළමයි? එහෙනම් good night everyone. Study well. If you are having further doubts, send them. තව කතා කරන්න. හොඳ review එකක් ලියන්න හැමෝම හොඳේ. හොඳට ලියලා එකක් ගෙනල්ලා පෙන්නන්න class එකේ. Okay? So good night everyone. Study well.
Recording stopped.